Welcome to a short little video on statistics. We'll call this statistics number 1. Here are some vocab you need to know for class. N represents the number of terms. Mode is the number that occurs most frequently. Median is the middle number when arranged in numerical order. If you have an even number of terms, please average the two middle numbers. Mean, add up all the terms and divide by n, otherwise known as average. The range is the highest number minus the smallest number. So don't leave an interval for a range, leave a number. Like 5 minus 1 is 4, the range is 4. Outlier is a number that seems a lot higher or a lot lower than most terms, and you may omit that depending on the situation. On the next slide, we're going to actually calculate all of these terms. So please make sure you know your vocab. All right, let's take a look at the following data set. It's random, so here we go. 5, 7, 9, 3, 7, 6, 2, 2. So let's have a look at all the things that we need to find n. Well, n is the number of terms in our data set, so if you count them up, you find that n is 7. The mode is the number that occurs most often, and in this case, mode is also 7. If no number repeats, the mode essentially is each of the individual number in the term in the set. Median is the middle number. So if you can see here, I have arranged numbers from the lowest to the highest and found the middle number, which of course, again, unfortunately, is 7. The mean. If you look to the right here, I have added up all the numbers. They add up to 59. I have divided by the number of terms, n, and the mean, rounded up to 2 decimal places, is 8.43. The range. Well, our high number is 22, and our low number is 3. So what is 22 minus 3? Well, that's 19. So the range is 19. Let's look at our data for a minute. Does any number look out of the sorts? Well, maybe the outlier is 22. We don't know enough about this random data set, but for now, I'll leave it at 22. These are the basic calculations you should be able to do with any data set. All right, let's have a look at the formula for standard deviation. The old school way, we're going to start with just the calculations. So here's the symbol for standard deviation, and here's the formula. It looks intimidating, but it's actually pretty straightforward. It's the sum of the difference between each term and the mean squared divided by all of the terms. So in order to start standard deviation, you need to know what is the average or the mean. You need to know n, the number of terms, and you should have your data organized in a simple table. It'll help you do the calculations. So let's do it. All right, let's take a look at calculating standard deviation using the formula. So here are some test scores: 75, 82, 95, 78, 96. When we're using the formula, the first thing we need to find is the average. So if you add up all the terms and divide by 5, 85.2 is the mean. So now we make a little table. We put all of our first terms in the first column. We do x minus x bar. Remember, x minus x bar is just the term minus the mean. So we do that for each term. And then we square the difference. This takes care of the difference. For example, 75 minus 85 is minus 10, but minus 10 squared is still positive, versus a couple down, 95 minus 85, which is almost 10, and 10 squared is almost 100. So this takes care of the above or below the average, and it all comes out in the wash. So you take them, you subtract them, and square them, and then you add them up. So the sum for these was 378.8, and if we divide it by n, which is the number of terms, our standard deviation is 75.76. So essentially, we'll have a look at what that means in the next round, but for now, that's how you do standard deviation calculations using the formula. Don't forget, the very last step for standard deviation in the formula is the big square root. So here we go again. The sum was 37.8. I divided that by 5, which is a number of terms, 75.76. And the last step is take the square root of that, which gives us a standard deviation of 8.70 units. All right, let's look at the same data, but using StatCalc. Now, I like StatCalc for an app because it's free. However, one of its shortcomings is it hates decimals. So I can't use 7.5, 8.2, 9.5, 7.8, 9.6. unless I pay the 99 cents to upload it. So for those of you out there who have found a great app that lets you use decimals, please let us all know. But here's a nice thing about an app like StatCalculate, or a better one, is that it gives you all the information you need right away. So what's the number of terms? 5. What is the sum of those terms? 426. What's the range? 21. What's the mean? 85.2. What's the median? 82. What's the mode? Hey, all of them, because there are no repeats. Population standard deviation is the standard deviation that we get when we do our calculations. So that's what you would be comparing it with. So if you look back on the previous slide, I had about 8.70 as well. Population variance is actually 8.704 squared, so that's the number before you take the square root. Sample standard deviation is a slightly different calculation where your n is less than 1 less, because they're assuming that there's other terms out there that you have to account for. And the sample variance is the same idea. So we only use the population standard deviation, and if you're doing a manual calculation, you will get the population variance. So here's a great way to do a lot of data calculations really quickly using an app. Let's have a look at calculating the standard deviation when using frequency tables. Now, for example, here's a chart from the textbook on page 235. It has daily calls and the frequency. So they've given you already in between 26 and 30 calls that happen twice, 31 to 35 calls that happen 13 times, and so on and so forth. So you can see that it's already creating a nice histogram where the numbers go small, big, 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 and then they get back down small again. So if you drew this, this looks like it's going to start to draw a nice normal curve. So what you need to do is a couple of things. The first thing is you need to figure out what is the midpoint of the interval. So what is 26 plus 30 divided by 2? 28. And since they all go up in steps of 5, once you see the pattern, you can just do that. So that's the midpoint which you need. Now, if you have the TI-83 or 84, I'm going to tell you how to do the standard deviation using the midpoint and frequency in the next slide. So if you don't have that, I haven't found a great app to do that, so you still have to do it old school way. So you'd have to take your midpoint and multiply it by your frequency for each of those, and I'll leave you to do that. So this is just sort of a quick one of how you do that. So you do that, and then you divide by the total number of terms, so that is your n value, and that gives you your x bar. And now, using the midpoint, to do the same thing we did on the other page. So you would do 28 minus your x bar and square it, so on and so forth, all the way to the bottom. You would add those up, divide by n, and don't forget to take the square root. So finding the standard deviation from a frequency table is quite a bit of work, because you have to find something that you don't know. You don't know what the average is. You don't know what the sum of all the terms is. And it's quite a lot of work. So if you're doing this for your project and you need to do this, it's quite a few steps to find the standard deviation. So if you stay tuned for the next slide, I'll tell you how to do it on your TI-83. All right, let's have a look at how you use the TI-83 or higher, 83, 84 plus, to do standard deviation with a frequency. So the first thing you have to do is do stat edit, and then I'll take you into the tables L1, L2. In L1, you want to enter your midpoints. In L2, you want to enter your frequency. Please make sure you enter the numbers correctly, otherwise you'll get an error later on called dim mismatch. And what that means is you may have 5 numbers entered in L1 and only 4 in L2, so you'll have to go back and fix that. Then you want to do second function 0. So that gets you to the catalog, and you can hit the LN button to get you closer to S. Then you're going to scroll down about 10 to get you to standard deviation. Then you're going to hit second function 1. That's going to put your list 1 in there, comma. So have a look at the comma button here if you haven't seen it. And second function 2, and that will get you your L2 entered. Then you'll close the bracket and hit enter. Then you will get the information you need on the screen. So that's the easiest way to do standard deviation when you have a frequency table. And if anyone finds a great app to do it, let me know.